Okay, so today we're going to continue with our study of distance, velocity, and acceleration. And really, we're just going to look at another option today that involves horizontal motion. So that's going to add one or two extra types of questions that we're going to consider. Again, the key today is to make sure that when you read these questions, you know what to do. The derivatives and all the work right now should be easy, but you should be able to make sure that you're focused on reading and trying to figure out what exactly do I do here all by myself. Okay, so here's our first scenario. We're going to look at the position of a particle moving along a straight line given by this equation right here. Okay, where t is greater than or equal to 0, t is in seconds, and s is, of course, in meters. So the first question here is, when is the particle at rest? Okay, so think quickly, what do you think that means? Okay, and hopefully you can figure out that that's going to mean when v at t equals 0. Okay, so of course I have to find v at t first by taking the first derivative, and so when we do that we get 6t squared minus 42t plus 60. And then I'm going to find out when is the velocity equal to 0, so I'm going to set this equal to 0 and I'm going to solve. And of course this is a quadratic, so I'm going to try factoring, and if factoring didn't work, then I would try the quadratic formula. And I believe factoring is going to work here. You try it yourself. Okay, and of course then I can see that the particle is at rest at 2 seconds and 5 seconds. Okay, and hopefully that makes sense and fairly straightforward. Let's take a look at question B. Question B says, what is the particle's initial position? Again, I want you to think for yourself. What do you think that means? Okay, that means we want to find the position, so S is our position function here at time equals 0, right? So that's what this question is all about, and I think you can see that it's pretty easy. We're going to sub in 0 for all of t, and we're going to, of course, get 0 meters, and you could write a therefore statement there as well. Okay, let's keep going. Okay, next question. C, when is the particle moving in a positive direction? Okay, so let's think about what this one means. This one's a little bit new. We already said that the particle is at rest when v at t equals 0. So the particle is moving in a positive direction when v at t is greater than 0. This is kind of like when we used to ask when we used to talk about the IROC, right, which we know is the first derivative, and when we talked about that was increasing or decreasing. This is very similar to that, right? Okay, and then obviously then we could see that a negative direction would be when v at t is less than 0. Okay, so for this question, if we return to our part C question, we're going to need to look at v at t, and we're going to want to find out then when v at t is greater than 0. Okay, so we're going to solve a polynomial inequality here. We have our v at t from our previous, we actually have it already in factored form, v at t, but we have v at t from the previous screen, so it was 6t squared minus 42t plus 60. We want to know when is that greater than or equal to 0. In factored form, that was 6t minus 5 and t minus 2. When is that greater than 0? Okay, so we know then that our t-intercepts, or the intercepts in this question, would be 5 and 2. And we could go ahead and set up our interval table and see what that gives us. Okay, so a really quick interval table here. We're going to have our options when t is less than 2. We're going to have between 2 and 5, and we're going to have greater than 5. Okay, we'll go ahead and plug some numbers in. So if we plug in a number like 1 in here, we can clearly see that we're going to get something positive. We're going to get two negatives that equal positive. Okay, if we plug a number like 3 in, we're going to get negative, but positive, so overall negative. And again, you can list all your factors at the left if you're still doing that. And if we plug a number like 6 in, hopefully you can see that overall it's all positive. Okay, so when is the particle moving in a positive direction? We have our answer here, and we have our answer here. So we'll just write a therefore statement. Okay, so the particle is moving in a positive direction between 0 and 2 seconds. Remember that this question was defined when t was greater than or equal to 0 and when the time after 5 seconds. Okay, so now we're going to use this idea in some other questions. Okay, and in order to use this idea, we're going to need to find out a couple of other things. So the next one is, what is the particle's position at 2 seconds and 5 seconds? So we know that that's when it sort of changes direction, that's when it stops, so we want to know where the particle is at that time. So hopefully it's easy for you to see that that is me asking you what is S at 2 and what is S at 5. So I'll give you a second to pause the video, go ahead and find those two answers. Okay, and hopefully you got 52 meters at 2 seconds and 25 meters at 5 seconds. So now, like I said, we're going to take all this information and we're going to apply it to the question, determine the total distance traveled, and we're going to sketch a diagram to illustrate the motion of the particle. Okay, so these are really the two new ideas that we're going to look at today. And in order to be able to sketch this diagram, okay, we are going to need to know its position at all of these times. So we're going to try to summarize all of the information that we have so far. Okay, so first things first, we're just going to set up a little position diagram right here, or axes. So that's our S at t. Okay, we know originally it started at 0 and just needs to be labeled. So we went a little bit above 50, and we're going to illustrate the horizontal motion, remember, of this particle. So at the beginning, at t equals 0, the particle is right here, right? So that's t equals 0. Okay, then what happens? It travels in a positive direction all the way up to 2 seconds, and we know from the previous question that it's at 52 meters. So somewhere over here, let's call that 52, at t equals 2 seconds. Okay, so the particle moves in a positive direction until we get to 2 seconds. Okay, and then what happens? Then between 2 and 5 seconds, it's actually traveling in a negative direction. Okay, and that's all the way to 5 seconds. And we know that at 5 seconds, the particle's position, this is at t equals 5. The particle is back at 25 meters. So the particle travels back here. Okay, and then what happens at 5 seconds? It changes direction again, and it moves in a positive direction for the rest of the time. Right? It's never going to change after that. So that's how we use the diagram. And now we'll take this diagram and we'll actually determine the total distance that the particle traveled in the first 6 seconds. Okay, so really important here, we need two things. We need to use the diagram above, and then we also need the initial and final position of the particle as well. Okay, so we'll just pause and write that information down. Okay, so we need the initial and final positions and when the particle changes direction. So we actually have all of these positions. If you look back already, we already knew S at 0. Okay, we already knew S at 2. We already knew S at 5. So the only piece that we're actually missing is S at 6, since I'm asking during the first 6 seconds. And you can go ahead and plug that in and see that you get 36 meters. Okay, so our total distance, we're going to add up all these different segments and how much was traveled. Okay, so in the first 2 seconds, you can see that it was 52 meters. Okay, and from 2 to 5 seconds, we traveled from 52 to 25, so that's, of course, 27 meters. Okay, and then from 5 seconds to 6 seconds would be somewhere around here. We traveled to 36. So from 25 meters to 36 meters is another 11 meters. And so the total distance traveled is 90 meters. Okay, so hopefully that makes sense to you. We're going to give you one of these questions as a warm-up tomorrow, so you can make sure that you understand and test out this process, and then we'll do some practice in class. See you tomorrow.